Hi, I'm Julie Darby, the narrator and author of this presentation. This presentation is about the mathematical calculation of installing solar panels to reduce Melanie's carbon footprint on the environment. But let's first get an understanding about solar power and carbon footprint. When electricity is produced using non-renewable resources like the burning of fossil fuels such as coal, this process produces greenhouse gases which causes damage to our environment, often referred to as carbon footprint. Whereas electricity produced using renewable resources like sunlight through solar systems, there are no greenhouse gases produced. So how do solar panels work? Well, as seen in this diagram, solar panels absorb the sunlight and convert the light into direct current or DC electricity, which then flows into the inverter, as you can see at item 2 in the diagram. The inverter converts the DC electricity into alternate current or AC electricity, which you can use in your home. Any surplus electricity that is not used by your home is fed back into the grid. And if you use more electricity than your solar system produces, electricity is drawn from the grid. Okay, now that we have an understanding of carbon footprint and how solar panels work, let's look at our mathematical problem. Here's the scenario. Melanie from Melbourne has been studying sustainable education and perspectives at Swinburne University. During this subject, she has learnt that her current electricity usage is damaging the environment. So Melanie has decided to install solar panels to reduce her carbon footprint, and she would like your help to work out what size solar system would best suit her current electricity usage, the costs, and any savings created. She has also provided us with her current electricity usage as being 5,793 kilowatt hours per year. So let's break down this problem. We will do this by using George Polyo's strategies for problem solving. First, we will identify the main elements of the scenario we need to work out. Then we will plan how to tackle each element. We will then work through the calculations for each element and finally come up with the answers to our problems. Okay, let's get an understanding of the problems. The first one being, what size solar system would best suit Melanie's current electricity usage? How much will the solar system cost Melanie? And thirdly, what savings will Melanie achieve by installing a solar system? Number 1, what size solar system will best suit Melanie's current electricity usage? Here is a table obtained from Clean Energy Council showing the average daily production for each capital city in Australia for various sized solar systems. The important information we need to note here is average daily production. Melanie has advised us of her annual electricity usage, therefore using this figure we need to work out what her average daily usage is so that we can look at this table and see which sized solar system would best suit Melanie's current electricity consumption. So the calculation is Melanie's annual electricity usage of 5,793 kilowatt hours divided by 365 days equals 16.36 kilowatt hours as her average daily usage. Based on her average daily consumption, we can now see that a 4 kilowatt system would be best suited for Melanie's current electricity usage. So the second part of our problem is, how much will it cost Melanie for her solar system? Well, using this table, we can see a 4 kilowatt system from Solar Choice would cost Melanie $6,787. Okay, the last part of our problem to be solved is, what savings will Melanie achieve by installing a solar system? But to answer this question, we need to break this down even further. We need to work out Melanie's current annual electricity costs. How many kilowatt hours will her solar system produce per annum? And then based on that, we'll be able to work out Melanie's new annual electricity costs once the solar system is installed. Then we'll be able to work out electricity savings achieved per annum. And finally, the length of time it will take Melanie to recover solar system costs through savings. Okay, let's work out Melanie's current electricity costs. We know that Melanie's current electricity usage per year is 5,793 kilowatt hours. Her electricity supplier, Energy Australia, charges a rate of 29 cents per kilowatt hour. So we multiply those two together to get Melanie's current electricity cost per year of $1,679.97. Okay, the next part is, how many kilowatt hours will Melanie's solar system produce? If we look back at the table we saw earlier, we will see that her solar system will produce an average of 14.4 kilowatt hours per day. So to work out how many kilowatt hours her solar system will produce per annum, we need to multiply the average daily production of 14.4 kilowatt hours by 365 days to establish the annual electricity production of a new solar system. Okay, the next part is working out Melanie's new electricity cost per year with her new 4 kilowatt solar system. Well, we know her current electricity usage is 5,793 kilowatt hours. We need to take away the electricity source from her solar panels, 5,256 kilowatt hours, to work out the amount that she still needs to get from the electricity grid, which is her shortfall or deficit of electricity, and that calculates to be 537 kilowatts. Her supplier's rate, Energy Australia, charged 29 cents per kilowatt, so therefore we need to multiply the 537 kilowatt hours that she has as a shortfall by 29 cents, and that'll give us her annual electricity cost of $155.73. Lastly, let's work out Melanie's electricity savings per year once she installs the solar system. Okay, so we now know her previous electricity costs prior to installing the solar system was $1,679.97. We need to then take away her new electricity costs after installing the solar system, and then the difference between the two equates to the annual savings of $1,524.24. Therefore, the length of time it would take Melanie to recover the solar system cost through savings would be approximately 4.5 years. This is calculated by dividing the total cost of the solar system by the annual savings achieved. Overall, this is a great outcome for Melanie. By installing a solar system, she will be saving money as well as reducing her carbon footprint.